And we are good to go. Welcome to another session. The last time we met, we discussed the introduction into the data analytics and research. My name is Elizabeth Boy. I will be the facilitator for your sessions. Today's topic, we're going to discuss the Z-score and how to find the normal probability. And here it means you need to make sure that you know where or how to read the tables. If the tables are not given to you in your study guide, probably they are in your prescribed books, if you do have prescribed books. Otherwise, they should have given you a tutorial letter with the tables, because you will require those to look up the values for your normal probability or your normal distribution probabilities. And that's what we're going to go through today. Okay, but before we start with today's session, let me give you an overview of or the objective of what we're going to be covering today. So by the end of the session, we will cover the basic concepts of normal probability. Because you need those concepts, they are also part of the building blocks towards learning more other things as you go along with your module as well. You should be able to calculate the Z-score and also interpret the values of your Z-score. And also we should be able, by the end of the session, know how to read the normal table to find the normal distribution probability. There will be some activities right at the end of the sessions that we're going to look at, just to give you an idea of the types of questions you get in your assignment as well as in the exam. So when we calculate a Z-score, what we're trying to do is to normalize the data. Like we discussed the previous time, that at the end of the day, you want to make sure that the results you compute or the information you get after analyzing your data, you want to infer it back to the population of study that you want. But sometimes there are technical things that you need to also take into consideration. For example, is to ask yourself, is my population normally distributed? And how do I check those things? And how can I find out if my population is normally distributed? And usually when your population is normally distributed, then it makes it easy to create those hypothesis testing and make your decision based on that and infer back the results back to the population. So today we're just going to learn the concept of that normal distribution, of what do we mean by saying things are normal. And to get to understand that, we first have to understand that we need to normalize our data units. We need to take them from whatever the distribution that they are at. Probably maybe they are uniform distribution or other exponential distribution, but we want to take them in and convert them to becoming normal distribution. And what does that normal distribution mean? So a normal distribution is always, or is usually represented by a belly curve shaped graph, where the center of that belly shaped curve will represent or will tell you the shape of or the distribution of your data, where in the middle you have the mean. And if your mean is the same as your median, the mean is the average, and is the same as the median, which is the middle value of your data point, or is the same as the mode, which is the most frequent number in your data, then we will say that data set is normally distributed. And if your data is not normally distributed, then we need to standardize it by calculating the Z-score and go and find the normal distribution of that data. And that is, oh, sorry, I clicked too fast. And that is a normal distribution. And these are the properties. As we go along, we're going to also unpack what does that mean, this normal distribution, and what does these values underneath this belly curve represent. So the area underneath this curve is what we call the probabilities. So we are able to calculate or find the probability of this normal distribution. In order for us to find that probability, we're probably going to use the observation themselves, the mean value, and the standard deviation. Where the standard deviation, here we're talking about the standard deviation of this population. So for a normal distribution, it will always have a standard deviation of 1. So what we're saying is a normal distribution will always be a standard normal distribution with the mean of 0 and the standard deviation of 1, because right in the middle here, it will be 0. And the area underneath the curve, the sum of it will always be equals to 1. Therefore, it means if we have to find any probability underneath the curve, it will be a decimal probability. And if we find the probability of everything underneath the curve, it will be equals to 1. So in the middle, when you split this on the left-hand side, this is the left-hand side. On the left-hand side, it represents 50% of the data. On the right-hand side of the mean, 0, it will represent 50% of the rest of the data. And those are the probabilities. And we're going to learn about those probabilities and how do we find those probabilities as we go along. So in terms of a normal distribution, the other property that you need to know is when the value of your mean of your original probability or your original data set changes, the mean will shift, or the graph shifts either to the left or to the right. It depends on the size of your mean. So it will only move from left to right. But when your standard deviation value increases, then your graph becomes narrower or shorter, or we say it moves up and down. So it increases in terms of the spread, because then the standard deviation, at this point, it is 1 standard deviation. When it's 2 standard deviation, the graph will be flatter. So the graph might be flatter like that. Maybe I'm not drawing it properly, so I must just take it out a little bit. So if this is 1 standard deviation, a 2 standard deviation might be like that, because you can see that the deviation from the mean, the spread from the mean to the outside of the graph, it's bigger. And therefore, the graph also becomes flatter. And for a 3 standard deviation, the graph might look just like this. As you can see, that the distance between the outside and there also grew to a 3 standard deviation. I'm not drawing it roughly, but just to give you an indication. So with the original one, we would say that was 1 standard deviation. This we can say it is 2 standard deviation, and this we can say it's 3 standard deviation, because when the value of your standard deviation increases, the shape of your normal distribution also changes. So how do we translate your original data into making them standardized normal distribution data? We do that by using the Z formula. And the Z formula, which is the Z-score, we also call it the Z-score. It takes your X value and standardize it by subtracting your X observation from, as it's your X observation minus the population mean, divide by the standard deviation. And with this formula, we can also use it to find the probability, which is the area underneath the curve. But this is how you standardize your score. Using the Z value, you can also use it to compare and look at whether there are differences between different, let's say we have marks. Students have written the exam, and we have exam results for physics, for maths, and for chemistry, and we want to see the performance of those three subjects. We can also calculate and look at the standard deviation and look and see which of the three subjects you are performing better than the other. Or we can also take the same subject and compare the students and look at the difference between how the students perform, who performs better than the others. So you can use the Z-score to do that. So how do we then calculate or standardize the data? If X is distributed with the mean of 100 and the standard deviation of 50, the Z value, we need to find the Z value for where X is equals to 200. So it means we're going to substitute into our Z-score formula our mean, which is our population mean of 100, and our standard deviation of 50. So our X is given in the question. So we say 200. So our X is 200. 200 minus the mean of 100 divided by the standard deviation, and we find that it is 2.0. Now, I'm using 2.0. I'm leaving it to 1 decimal. What I'm going to tell you is always leave your answer to 2 decimals. So here we should add another 0. So the answer should be 2.00. Always remember to leave your answers in 2 decimal. And the reason why we leave the Z value in 2 decimal is because if we have to go and find the probability or the area underneath the curve that corresponds to this X observation, then we will need to have a 2 decimal value because the table has 2 decimals. So how do we interpret the Z-score? This is how you're going to say it. Your X of 2.0 of the Z value of 2.0, you interpret it by saying that for the X value of 200, it is 2 standard deviation or 2 increments of 50 units above the mean. So it means if we have different data points and this is our mean, I'm going to call it this is our mean, and we say at this point is one standard deviation, 2 standard deviation, 3 standard deviation, 4 standard deviation, 5 standard deviation, if there is such. So if the answer here, if we're going up, therefore it means it's positive. If we're going down, there are negative standard deviation, -1 standard deviation, -2 standard deviation, -3 standard deviation, -4. So what does this mean? It means this 200 is sitting at a 2 standard deviation. So the point is right there. So it's sitting, if we look at the distance between that point and the mean is sitting at that. If the answer here was -2.00, we would say it's sitting at this point, which is 2 standard deviation. If the answer here was 1.5, we would say it's sitting somewhere in 1 standard deviation. It's 1.5 standard deviation, it will be there. If the answer was 3.557, let's assume that would be the answer for one of the Z-score, we would say, we go to the bottom, the negative side, and we say 1, 2, 3, 5, 7, 5 will be somewhere there, and we'll say that point is sitting at -3.57 standard deviation away from the mean. And that's how you will interpret this. And with that, it also gives you an indication, and you can compare which values are closer to the mean or closer to one another, and which one is performing worse than the rest. So we can say this last point is performing worse than the others. This one and that one, they also performing worse, but this one is performing because it's closer to the average. It might also not be performing well, but that one might be performing more than the average, things like that. And that's how you're going to compare or use the values of different data points to compare them using the Z-score. So let's look at this example. The marks in different subjects of Patrick high school pupil are represented in the table below. His marks for different subjects are given along with the mean, the standard deviation for each of these subjects for all the learners in his class. So Patrick's marks, yeah, the mean of the class and the standard deviation of the class. So Patrick's marks are what we call the X observations. The class average is what we will use the mean for, and their standard deviation. So it means how far apart each of Patrick's class results are different from each other. Okay, so the question is saying, so also you must remember that it's for each subject area. Use the information in the table to answer the questions below. In which subject did Patrick do better relative to his class? So it means we're going to have to calculate the Z-score and look at the results of the Z-score and say which one is better than the other. Because by looking at only Patrick's score, we can say he performed better in history. But did he perform better in history relative to his class? His class performance is 75% in history. So in order for us to know which one of this subject he performed better, we need to calculate the Z-score. So let's first calculate the Z-score for mathematics. So to calculate the Z-score for mathematics, you've got two choices. Because these are percentages, you can decide to divide the percentage by 100 to get it to a decimal, or you can use it as is because they are all percentages. It will not make any difference. So, but in mathematics, if I wear my mathematics hat, I'm going to change the percentages to a decimal. And then the rest of them, I'm not going to change them to a decimal. I just want to show you that you will still get the same. So the formula is Z is equals to X minus the mean divided by the standard deviation. So we're calculating for mathematics. Patrick's was 0.56 minus the mean of class is 0.42 divided by the standard deviation of 0.06. And the answer here we will get, just want to do the calculation, 0.56 minus 0.42 equals divide by 0.06 equals 2.33. 2.33. That is, if we convert them to a decimal. I just want to also show you that you can still get the same answer if I don't convert the percentages into a decimal. So I'm teaching you wrong, but this will save you time because they are all in percentages. So 56 minus 42 divided by 6. Let's see if we get 2.33. So you will get 56 minus 42 equals divide by 6 equals 2.33. So in order for us to save that time, we're just going to use the percentages as they are, and always remember that these are percentages. So we've calculated the Z-score for maths is 2.33. So we need to calculate for the rest of them. So for science, it will be Z of 54 minus 54 divided by 4, which will be equals to 0 because 54 minus 54 is 0. So I don't even have to divide 0 by any number. So that will be 0. For geography, we get Z of 62 minus 50 divided by 8. So how do we get 62 minus 50 equals divide by 8, and we get 1.5, 1.5. So for this one, it will be 1.5. Okay, and for history, it is Z of 68 minus 75 divided by 5, which is 68 minus 75 equals divide by 5, which is minus 1.4, minus 1.4. By looking at the result of your Z-score, which one would you say Patrick's subject, he performed better relative to the class? It will be the results where you have the bigger Z-score, because the bigger the difference of your Z-score, it tells you that you did much, much better than the rest of the class. But it also has to be positive. If it's negative, it means you did worse than the rest of your class, or less than the rest of your class. So it has to be a positive, and the only one with a positive and is bigger is mathematics. So Patrick did best in mathematics relative to his class. And that's how you're going to use the data to compare and find your answers. Are there any questions?
So far, it's clear for me.
Cool. So if everything is clear, then let's move on to the next best thing. And that will be, how do we use those Z standard normal distribution or standardized values to find the probabilities? So finding the probability, which is the area underneath the curve, remember, the area underneath the curve, there are certain rules that you always need to bear in mind. We are going to find the probability of a less than, the probability of a greater than, the probability of equal, or the probability of between. Usually the probability of equal, which is at the point for a normal distribution, that probability is equals to 0. So if they say find the probability at this point, the probability at that point will be the same as at that point. So it will be equals to 0. So the probability of x is equals to x. For a normal distribution, it will be equals to 0. That you need to always remember. However, because we're working with a cumulative probability, so we're going to calculate either the probability of a less than. So what helps me mostly when I tackle questions of normal probability is drawing myself a normal distribution curve and shading of the area that I am calculating. So for example, if the question is calculate the probability of x is equals to, or x is less than a value, which means it's less than or at most, therefore it means they are saying I must calculate the value of a less than, regardless of whether it's positive or negative. So anything after 0, this side will be negative. Anything after 0, this side will be positive. So if I have shaded this area, therefore it means my A is negative. I am looking for the probability of A less than. So now, since my area that I'm looking for is shaded, it also helps me understand which probability I'm going to be looking at, because this shaded area is small as compared to the shaded area. Therefore, it means I'm going to be looking at the smaller portion of the table. So you will see now when I explain the table to you. If I'm looking for the probability of the non-shaded area, therefore it means I'm going to be looking at the positive, which is the non-shaded area will be the larger portion. If I'm looking only at this point, the less than A, I'm looking at the smaller portion. Okay. So what if I'm looking at the shaded area this side? So if this is my shaded area, starting from there, because now I'm shading everything. So this is my shaded area. As you can see, I've shaded it. So therefore, it means this shaded area, because it comes from the positive side, I'm looking at the larger portion. So the probability will be bigger as well. Whereas with this one, the probability will be on the smaller side. So how do we do that? So the table looks like this in terms of your normal distribution table. So the probabilities associated with your standardized normal distribution, I found this table from your past exam papers. Usually the previous past exam papers were handwritten or hard copies, so you should be able to find it somewhere online as well. So how do we read this? This will be our Z value. We're going to introduce the mean to Z later on when we look at the between. We're going to, when we look at the shaded area, if the shaded area is the smallest, if it's only this portion that is shaded, we're going to look at the a smaller portion. If it's this side that is shaded, then we're going to look at the larger portion. For the mean to Z, it means we're going to be looking at the between. So for this one is the between. Any question that has to do with between, we are going to use that. Any question that the shaded area is the smallest, we're going to look at the smaller portion. If the shaded area is big, we're going to look at the larger portion. So think about it in that way. So how do we do that? Finding the normal probability. Let X represent the time it takes in seconds to download an image file from the internet. Suppose X is normally distributed with the mean of 18 seconds and the standard deviation of 5 seconds. Find the probability that X is less than 18.6. So always remember, the mean is given. The standard deviation, which is sigma, is also given. So you have the two. Your X is always going to be in the question as they ask you. So we're going to we can draw a graph that represents that scenario. And we want to standardize this. So when we represent this, our 18, because our mean is right there at the middle, it's 18. Our X is 18.8. So, and the question is less than, and less than means to the left. Shade the area to the left. So it means we're shading this area to the left. Looking at the area to the left as compared to the area that is not shaded. Therefore, it means when we calculate or standardize the data, this area is the larger area. Because this portion that is left is small. So it means we're going to find our answer in the larger portion. Okay, let's see how we calculate this. So we know our standardized normal distribution table or formula. It's X minus the mean divided by the standard deviation. Our X is always in the question. It's 18.6 minus the mean of 18 divided by the standard deviation of 5. And the answer we get is 0.12. And that, taking our data, transforming it into a standardized normal distribution. Our mean, remember, always Your normal distribution is distributed always with the mean of 0 and the standard deviation of 1. So taking that into consideration, we have calculated the Z value, which is the Z-score, and we are looking at this portion. And as compared to the area that is left, this portion is larger than that portion because this portion includes the 50% plus some little bit of the other 50% of the other side. So therefore, it means this is the bigger portion, it's the larger portion. So in order for us to find this probability, we go to the larger portion table. We look for our Z of 0.12. So we go and look for Z of 0.12. As you can see, all the values are in 2 decimal. You always need to remember to leave your answer in 2 decimal. 0.12, and then we go to the larger portion, and where they both meet, that will be your probability. So the probability of X of less than 18.6 is 0.5478. And if we need to put it into proportion, we can say multiply that answer by 100 and it will be 54.78%. But that's how you find the probability of A less than. How do we find the probability where we're looking for the probability of a greater than, regardless of whether it's in the negative side or in the positive side? So if we're looking at this picture, this is in the positive side, so it means our Z here is positive and we're looking for Z of greater than A. Therefore, we're looking at this small portion as compared to the unshaded area, which is the larger portion. If we have to look for a probability in the negative side, but greater than, therefore it means it's going to include that shaded area, then it means we're going to look at the larger portion. But for this one, for our example on this screen, it means we're only going to look at the smaller portion. So let's look at an example. Suppose X is normally distributed with a mean of 18 and the standard deviation of 5. Now find the probability of X greater than 18.6. So I draw myself a little diagram because I want to visualize the concepts so that I know when I go and look for the value on the table, I know which side I'm going to look at. So there is my value of 18.6 and it is in the smaller area. Right, so let's standardize this data that we have. Standardizing the data, we calculated this earlier, remember it's the same values, so you will say 18.6 minus 18 divided by 5, you will still get 0.12 because we're using the same information. So since we're looking for 0.12 and we know that we're looking for the smaller portion, therefore it means we go to the Z value of 0.12, but we're looking at the smaller portion where they meet. That will give us the value of the smaller portion. The same thing, the sum of these two values, the larger portion plus the smaller portion, will give us 100 or will give us 1 or 100%. So if you add these two values, they will give you 1 or 100% because the sum of all probabilities or the sum of all values underneath the curve, it's equals to 1. But this is how you will find the value or the probability of a smaller portion. So how do we then find the probability of the between? If we need to find the probability where Z lies between two values, so they will say it lies between A and B, so we're going to shade that area. We can see that it is just the small area. It is not 50% of that area or 50% of this area, but this small portion that is on there. So you cannot use the smaller portion or the larger portion because smaller portion and larger portion, they represent the cumulative probabilities underneath. So therefore, it means for the between, we are going to use mean to Z. How do we do that? We're using the same data set here. Suppose X is normally distributed with mean of 18, standard deviation of 5. Find the probability that X lies between 18 and 18.5. Likewise, we calculate the Z-scores. The Z-score for 18 is 0. The Z-score for 18.6 is 0.2. We calculated that. Now, because we are interested in the value from this point to that point, that's why we use mean to Z. And because we use mean to Z, we can just go to the bigger one, to the 0.12 and ignore the 0 because 0 is where we're starting at this point. So we go and look at 0.12. Mean to Z. So when you go to 0.12 mean to Z, you go 0.12 and we look at mean to Z, and that will be the probability. If you do not want to use the mean to Z, remember we had the probability of Z lies between 0 and 1,2. You can also use this formula, because with this formula, you can use the larger portion or the smaller portion, but usually the larger portion. So what you will do is you will take the second side, subtract the first value. So you will take the probability of the first one, oh, sorry, the probability of the second one, subtract the probability of the first one. And you can rewrite it in this manner so that you know what you are looking at. So you go to the larger portion, you take the probability of 0.12, which is 0.478, minus the probability of 0, which is 0.50. And when you take the difference, you get 0.0478. You can either use the two, but I prefer to use the mean to Z because it's easy to get the values. Usually, when it is not a 0, then you can add the two values on the mean to Z. So you will take the probability of 0, because here the probability of 0 is 0. So 0.00 plus 0.0478 will give you 0.478 again. If it was another value, let's say it was the probability of 0.01, so we will take 0.040 plus 0.0478 to find the value that we are looking for. Okay, maybe let's do more examples so that you can see how everything works together. Look at the graph based on the frequency distribution of the measurement of the variable of X from normally distributed data, which is produced below. Using the information provided in the graph, calculate the probability that a measurement made at a random on this particular scale will fall in the area under the curve, colored in gray. So if you look at this picture, the graph colored, the graph where it's colored in gray, you can see that we're looking at the between. So it means if we need to answer, select the answer which is closest to the probability from the options below. So if we want to calculate the probability of this graph, we will also have to use mean to Z, because this is a mean to Z type of an question, because it's between. So we first need to calculate the Z. So the first X is 25, the second X is 50. So X minus the mean divided by the standard deviation. Our first X is 25 minus our mean of 40 divided by our standard deviation of 10. Our second X the mean divided by the standard deviation, that will be 50 minus 40 divided by 10. So let's calculate each one of them. So 25 minus 40 equals minus 15 divided by 10 is equals to minus 1.5. Next one, it's 40, 50. 50 minus 40 equals divide by 10. And the answer is 1. So we need to find the probability that X lies between, that was the question, X lies between 25 and 50, and we found that it is the same as the probability that Z lies between minus 1.5 and 1. So because I'm using the table, I'm going to say minus 1.50 and 1.00. So we're going to go to the mean to Z. And I use this, let's go back there, minus 1.5. Let's look at the table that I have. I don't have the ones, so let's see if I do have another table with the ones. I don't have the table with the ones. So just bear with me. I'm going to look for a table with the ones. I'm just going to stop sharing and share again. And then I will come back to I hope everybody can see. I'm gonna make it bigger. Scroll down till you get to 1 and 1.1. So the two values we're looking for is it's 1.5 and 1. We're looking for two values. Okay. So 1.5 is, you must write it down, 1.5. So 1.5, it's somewhere at the bottom. That is one of the values. So write that value down. It is 0.4332. That is one value. And then we're also looking for 1. So we're also looking for 1 mean to Z. So 1 is here. The mean to Z is that. Which is, I'm writing the value down, 0.3413. Okay, let's go back to our presentation. It's a mission to toggle between different. I hope you are able to see the slides. So it will be 0.34. 0 plus 0.3413. So plus, so we just add them together, 0.4332 plus 0.3414 equals, and the answer is 0.775. If we round it off to 3 decimal, and the answer will be option number 2. And that's how easy it is to find the probability. Are there any questions before I share with you some of the example exercises, activities that you can also do? We can also do 1 or 2 of those exercises. Are there any questions, any comments? Okay. In the absence of comments, so I hope everybody understands how to find the values on the table. So let's look at more activities or some of the activities, and then you can also do the activities on your own. You can go and find some of the activities. So question 1, an educational psychologist measures the general knowledge of 100 learners on the questionnaire with 50 questions. She finds the mean and the standard deviation of the scores of the scores are 20 and 8 respectively. So it means 20 is the mean and 8 is the standard deviation. The question is, what is the Z-score corresponding to a test score of 14 on the general knowledge test? And that is your activity. So the formula is Z is equals to X minus, remember X is always given in the question, minus the mean divided by the standard deviation. Let's see if you can get this one without my help. Which one? Is it option 1, 2, 3, or 4? Remember, when you are doing this on the calculator, you must say the value of X minus the value of the mean equals, so that you get an answer. If you do straight away calculation and you put, let's assume I'm going to just do it for you as well. So let's say this is 14 minus 20 divided by 8. On your calculator, if you say 14 minus 20 divide by 8, what your calculator will do is it will apply what we call the BODMAS rule. And the BODMAS rule says brackets of division, multiplication, addition, and subtraction. It means division and multiplication has priority over addition and subtraction, because your equation would be 14 minus 20 divided by 8 that you put on your calculator. What it will do, it will first resolve this. It will take 20 and divide it by 8 and find the answer. It will say 20 divided by 8 equals 2.5, and say 14 minus 2.5. That's what you will get. And that will be incorrect. This will be incorrect. So the best way to answer this question, we will say 14 minus 20 equals, and then you say divide by 8. And you will get the answer. What is the answer?
It's option 3, negative 0.75.
Negative 0.75. Which is option 3. That's how easy it is. So let's go to question 2 and see if we can answer that one, which is the same question. So Question 2 follows from the same information. So if we calculated the Z-score, because this one says find the probability that a specific learner obtain 14 or less on the questionnaire. So what does that mean? It means you need to go and find the probability that X is less than or equal, because it's 14 or less than 14. We already calculated the Z-score. We know what the Z-score is negative 0.75. You can even go and calculate it again if you want. So the probability that Z is less than or equal negative 0.75. Now, here is when you need to use that graphic method that we have. So let's draw our normal distribution. I'm not artistic, so don't judge my graph. We always know that in the middle it's 0, right? Is our mean. Our mean is there. So our Z of minus 0.75. So we're not going to use this value here, but we're going to rely on the value of the Z. So because here is our Z and this side is negative. My pen, why are you crying now? This side of Z is negative and this side is positive. So this is negative 0.75. So we're going to assume that it is somewhere on this side. It doesn't matter whether I draw it next to the 0 or I draw it there. It will not make any difference where I draw it. But it is somewhere in the negative side. And we also know that it is on the left. If it says greater, it's on the right. Less, so it means I'm going to shade this side. So you just shade the side and voila. Tell me, is it on the smaller portion or is it in the larger portion that we are looking for? Are we looking for the bigger or small? Is the area shaded smaller or the area not shaded bigger?
I think it would be the smaller portion.
It is smaller portion. So it means we're going to go to the table and look for 0.75 on the smaller portion. So we go 0.75 and we go to smaller portion where they both meet. And that will be the answer that you are looking for, which is 0.2266. Happiness, which is option 1. Are we good off?
Yeah. Thank you.
Yes, we are good. And since we left with only 2 minutes, I am not going to cover everything. So I'm going to leave you with this question. I think there are two questions that you can also do on your own. So I took this from the past exam paper as well. You will need to calculate, do it the same way as we did with the Z-score for the mathematics and the subjects and all that for Patrick. You can do it for John, even though this is not in a table format, but the same concepts are still similar. So use the Z-score to decide which statement is true relative to the rest of John's class. So you need to check whether John performed better in biology than in history, or better in history than in biology, or equally well in history and biology by comparing the Z value. Remember, if it's negative, it means it's worse. If it's equal, then it means they perform the same. If it is positive and it's bigger, it is better. So look at that and compare the values. The next one, not always that you're going to have to calculate the values of Z and all that, but they will ask you questions in terms of the concept. Do you know the properties of a normal distribution? Always remember that normal distribution is distributed with the mean of 0 and the standard deviation of 1. So you should be able to answer this question, which one is which, because here they gave you a blank and a blank. A mean of a blank and a standard deviation of a blank, you should be able to answer that question with ease. What I've also noticed is most of the exam questions, assignment questions are almost similar over the years. So if you practice more and find more questions, the chances are you will do better and you will do well. It's just finding clarity on some of the issues so that then it makes it easier for you to study better. And that's where we end today. But before we end today, I also want to introduce to you who I am, especially for those who don't know and think that this is UNISA work. So who are we? We are Phambili Analytics. Our mission and vision is to see more people succeed, especially in the field of statistics, data research, and data science. We're trying to bridge the gap in data literacy. That is our mission. That is what we have been doing, and that is what makes us tick as an organization. We are just trying to close those analytical skills and the data literacy skills so that people can be better at making decisions, as well as nowadays we know that data is the new oil because of technology, the new technologies like AI and all that, they rely on data. If you don't know how to interpret that data, you will be left behind. So these are some of the skills that you learn in your modules, but you can also take them through in life and learn those. And that's what Phambili Analytics does. Some of the things that we do, not only just focusing on data literacies, but we offer a range of services. We do consulting in data analytics, data science, research, and also our flagship is mostly on skills development because we care about the people and we care about upskilling our own and making sure that no one is left behind. In terms of the types of training sessions that we offer, we do online and virtual or face-to-face training. Usually our training are 350 per hour, but we've been running a special of 150 per hour for this year. We also offer self-led online training, but this mostly on your research methodologies, research design, data analytics, rather than your normal statistics type of university module type of courses, because then we are duplicating what you already have on your MyUNISA system or your university system. So we will not even suggest that you sign up for those ones. The other thing I also need to mention before you leave is you can go to the YouTube channel. You know that everything that we do online now, the 1 hour is for free. Nothing actually happens for free. So in order for me to support and sustain the channel, I need also a little bit of support. So please go and subscribe, share, but mostly join the channel, because the more, when you join the channel, you will receive the following benefits. So you also need to make sure that you join on the right benefit, because they've got different levels of membership. So we've got loyalists, and those are the benefits, appreciators and promoters, but we also do have other 2 low-level membership for those who just support and like my videos and watch my videos. But also, not only that, you need to also join as a member. Most of the PYC3704 material is already on the free portal site, where you can watch, binge watch, rewatch, free of charge. The videos are there. I think we've got 2 years of content on YouTube that is free, you can watch. But for these sessions, the free sessions that we're doing, you will have, in order for you to get the recording as well as the notes, you need to subscribe and enjoy the rest of your evening, unless if there are any other questions? Thank you.
Thank you so much, sir.